In order to create an unbiased linear model and prediction, our group decided to select randomly 5 years from the data given to us. We then applied and tested this on another random year before we applied it to the 2011 data just to make sure our model was accurate. We also saved the files as CSV files in order for R to run the code properly. When we first started looking at randomly selected years, we noticed that there was a lot of unnecessary data. We decided to cut all the variables and columns from the Excel documents in order to speed up the calculation process and make it easier for us to look at. We noticed that all the data needed a new column, which was the injury indicator. We specified a fatal injury as 1 and all others 0, since the focus of our testing is to see how many individuals have died from an accident.
To construct this model, we used a 5-fold cross-validation and trained the data. We created 5 different linear models to predict each of the 5 randomly selected years. Each linear model is dependent on 4 variables. Given the 3 variables of sex, root, and state, we decided to use age as our 4th variable. To assess the strength of our linear model, we used the leaps function to create a plot which allows us to analyze whether or not the variables we chose have an effect on the prediction strength using the BIC value. In the graph, the variables with the smallest number in colored black means those variables are the best to use. Based on our analysis of this plot, we were able to confirm that age was the best fourth factor to utilize in combination with sex, root, and state. Using the estimation column, we can create the linear model based on the 4 factors of sex, age, root, and state.
In order to get an accurate model and ultimately an accurate prediction for our 2011 data set, we created a 5-fold cross-validation model. In order to perform the 5-fold cross-validation, we used 4 of the selected years to predict the 5th. This process is repeated 4 more times so that each year has a predictive linear model based on the other 4 years of randomly selected data. Each of the test predictions for each of the 5 datasets consists of an R-bind, then a linear model is created that will be used to calculate the prediction value for the dataset. Next, we created the prediction using the predict function, and finally a C-bind is used to combine the prediction column just made for the dataset which it predicts. To test the accuracy of all the predictions, we calculated the A over E value of the combined 5 chosen years and got a value of 0.999697, which, since it is very close to 1, shows the strength of our linear model. Additionally, we tested the model in 2007 data to check the accuracy of the model and got an A over E value of 1.01, which reaffirms the strength of our linear model.
Our overall goal for a linear model and cross-validation was to get the most accurate prediction for the probability of someone dying in a car accident, as well as the total predicted amount of people that died in 2011. By utilizing randomly selected years to create a linear model, there was no bias in the data. Likewise, the use of a 5-fold cross-validation with 5 randomly selected years of data should increase the accuracy of the prediction. To find our prediction, we used the R-bind function to combine all the rows in 2001, 2002, 2005, 2006, and 2008 data. Then we used a linear model to predict the injury indicator column using the 4 variables of sex, age, state, and root. With the prediction from our linear model, we used the C-bind function to create a new column in the 2011 dataset. Although we do not know the actual amount of deaths for our 2011 dataset, we are confident in the strength of our predictive model due to its previous accuracy of 101.48% for 2007. By using state, sex, root, and age as variables for our model, we were able to predict the number of fatal injuries in 2011 as 31,730.43.